Hello everyone, welcome to course of engineering mechanics. Well, engineering mechanics is a subject from first year engineering which is common to all branch. So let us understand what is engineering mechanics, and here I'll teach you some theory part as well as we'll also go for some of the numericals which are important from exam point of view. So let us proceed for engineering mechanics. Well, mechanics may be defined as that branch of physical science which deals with the study of resultant effect of action of forces on bodies in the state of rest or of uniform motion. So actually speaking, engineering mechanics is extension of physics which deals with the forces, which deals with the resultant force and the effect of resultant force on the body when body is at rest or in uniform motion. Well, mechanics can be classified as first mechanics of rigid bodies, second mechanics of deformable bodies, and third is the fluid mechanics. Now remember all of you, mechanics of rigid bodies, this is our area of interest because our syllabus is throughout, from starting from chapter number 1 to the last chapter, we are dealing with this particular part of mechanics. So basically when I'm applying force to any body and when deformation of that body is very minute, or we can say which is not considerable, then I'll assume that that body is a rigid body. When I'm applying force to any body and that body deforms by a considerable amount, then I'll call that body as a deformable body. So when I'm doing analysis of resultant force which is acting on a rigid body, then I'll call that as a mechanics of rigid bodies. When I'm doing analysis of a body considering that body is deformable, and now I'm doing analysis of resultant force, then I'll call this as a mechanics of deformable bodies. And last, when I'm doing analysis of force acting on a fluid, then I'll call it as a fluid mechanics. So we are basically interested in a mechanics of rigid bodies. Mechanics of rigid bodies can be again classified as statics and dynamics. So let us first understand what is statics. It is a study of effect of forces system acting on a particle or a rigid body which is at rest. So now here let us take example and understand it. So you can see that this lamp is hanged with the help of two support. Now considering this point, at this point very first force acting is weight of this bulb acting in a downward direction. So this will be weight W, that is first thing. Now this weight is action and reaction will be given by this two string, because these two string are attached, one string is attached to the horizontal surface and another string is attached to the vertical surface. So this both string will give reaction. Let me call this as reaction 1 and this as reaction 2. So basically here I am doing analysis of all these three forces which is acting on this particular center point, where this center point is at rest. So analysis of a force or analysis of effect of force on a body or a particle which is at rest, that is called as statics. Let us go for dynamics. It is a study of an effect of force system acting on a particle or a rigid body which is in motion. Now let us take example that this is a cannon, and here a cannonball is fired at particular angle with some velocity such that it will travel and then it will hit the target. Now here I am doing analysis of forces that are acting on this cannonball, and this cannonball is changing its position with respect to time. Such type of analysis where body is in motion is called as dynamics. So from this part it's very clear. When body is at rest, it falls under statics. When body is under motion, it will fall under dynamics. Now, this dynamics is again classified as kinematics and kinetics. So let us understand this both in detail. Let us start with first kinematics. It is a branch of a mechanics that concerned with the motion of object without reference to the force which causes the motion. So here I am doing analysis of a body that is under motion, but here I am not interested in the force that causes the motion. In other words, I am not interested in the mass of the body. So where I am interested? I am interested in the geometry of the motion. So I am interested in displacement, distance, velocity, acceleration, and so on. So when I'm dealing with the geometry of the motion rather than force that causes a motion, then it is called as kinematics. So remember that in kinematics we don't consider mass of the body, and hence I can also say that I'm not considering forces that are causing the motion. I'm interested in the motion of the body. Now let us go for a kinetics. It is a branch of a mechanics that deals with forces that causes the motion of the object. Now here I have to consider the mass of the body, and when I'm considering mass of the body, forces that are acting on the body will consider. So here I am more interested in the amount of force that is required to achieve so and so velocity. So I'm more interested in the force part. So that is how your syllabus is divided among this part, that is statics, dynamics, and then dynamics is further classified as kinematics and kinetics. So let us have a quick look at your syllabus. So first is what we are doing right now, that is introduction to engineering mechanics, and then we'll go for introduction to statics. You can see that it is not important from exam point of view. Then first chapter we will start is centroid and center of gravity. Then we'll go for resultant, equilibrium, and friction. As you can see that starting from chapter number 1 to the chapter number 6, this entire thing is belongs to statics part. So here body which we are analyzing will be under rest. Then here we'll go for dynamics, that is introduction to dynamics. Chapter number 8, that is kinematics of particles. Majority of this chapter you have covered during your 11-12 standard. And then kinematics of rigid body. These two chapter will fall under kinematics, while chapter number 9, 10 and 11, that is kinetics of particles using various methods, that will fall under kinematics. So this is how your syllabus is divided among the statics, then dynamics, and then under dynamics kinetics and kinematics. Go for some basic parameters that are important to understand engineering mechanics. So first is energy. As we all know very well, what is energy? Energy is capacity or ability to do work. Energy can neither be created nor be destroyed. It can be transferred from one type to another type. Next is the force. So let us understand what is force. So very first thing, force is an external agency which changes or tends to change the state of rest or of uniform motion. So any pull or push sense that either causes or tends to change the state of the body. It may change the state from motion to rest, or it may change state from rest to motion. Under both the case, we can call that pull or push as a force. So this is a basic definition of force. To completely define force, we need four parameters. First is a magnitude. So usually we measure it in terms of newtons or kilonewtons. That gives me the magnitude of the force. Next is the direction. Then usually we give this in terms of angles with respect to x-axis or y-axis. Next is a point of application, that is a location of that force, that is at which point that particular force is acting. And last is a sense, that can be either pull force or it can be push force. So this is all about force. Now, few assumptions that we have made while solving the problems of engineering mechanics. Very first assumption is all the bodies are considered as a particle. Remember students, particle doesn't have any dimension. So whatever bodies are given in engineering mechanics will consider it as a dimensionless, and we can call it as a single particle. So we are not interested in the dimension of the body. Second, all the bodies are rigid. We can say very obvious assumption because we are doing mechanics of rigid body. So here we are assuming that all the bodies are rigid, and whatever force I am applying will be not responsible for change in the dimension of the body because body is rigid. And last, load acting on a body is a point load. Now actually speaking, point load is just imaginary concept. If I want to transmit any load, then some area will be required, whereas point doesn't have any area. But then for sake of simplicity of calculation, I assume that all the loads that are acting on a body is a point load. Well, this is a very basic and a theory part of engineering mechanics. With this, we have completed introduction to engineering mechanics with some basic concept like energy, force, and assumptions that we have made while solving the problem. Now in next session, we will go for theory part of centroid, that is our first chapter that will start, and after completion of theory part of centroid, we will go for the problems. Thank you.